about operating system, and let's talk about application management. An operating system handles the launch and management of every application. This typically supports an array of behaviors including time sharing multiple processes or threads, so that various tasks can share the available processes, time handling interruptions that applications produce to gain a processor's immediate attention, ensuring there is enough memory to execute the application and its corresponding data without interfering with another processes. Carrying out error handling can gracefully remove an application's processes and performing memory management without disrupting other applications or the OS. An operating system can also support APIs that enable applications to utilize OS and hardware functions without the need to know anything about the low-level OS or hardware state. And as an example, a Windows API can enable a program to obtain input from the keyboard or mouse, create GUI elements such as dialog windows and buttons, read and write files to a storage device, and more. Applications are almost always tailored to use the operating system on which the application intends to run. Additionally, an operating system can perform the following services for applications. In a multitasking operating system where multiple programs can be running at the same time, the OS determines which application should run in what order or how much time should be allowed for each application before giving another application a turn. It handles input, output, I/O to and from attached hardware devices such as hard disk, printers, and dial-up ports. It sends messages to each application and interactive user or to a system operator about the status of operation and many errors that may have occurred. It can offload the management of batch jobs, for example printing, so that the initiating application is freed from his work on computers that can provide parallel processing. An operating system can manage how to divide the program so that it runs on more than one processor at a time. All major computer programs, hardware and software require and sometimes include an operating system. And operating system must be developed with different features to meet the specific needs of various form factors. The next one is device management. An operating system is responsible for identifying, configuring, and providing applications with common access to underlying computer hardware devices. As the OS recognizes and identifies hardware, the OS will install corresponding device drivers that enables the OS and application running on the OS to use the devices without any specific knowledge of the hardware and devices. An operating system is responsible for identifying the correct printer and installing the appropriate printer's devices, so that an application needs to only make calls to the printer without having to use codes or commands that are specific to the printer. That is operating system's job. The situation is similar to the other devices such as USB ports, graphic processing units, GPUs, motherboard chipsets, and storage devices such as serial attached SCI, SAS disk adapters, and disks that are formatted with a suitable file system. The OS identifies and configures physical and logical devices for services and typically records them in standardized structure. It shows as Windows registry. Device manufacturers periodically patch and update drivers, and the OS should update them to ensure best devices performance and security. When devices are replaced, the OS also installs and configures new drivers. Operating system types and examples. Although the fundamental rules of an operating system are ubiquitous, there are countless operating systems that serve a wide range of hardware and user needs. General purpose operating system.